Hi everyone. Now I'm going to tell about you to how to use the logic design circuit software, and it's called Logisim. Here you can see the Logisim software. Now I'll move to the main menu of the Logisim. Here you can see File, Edit, Project, Simulate, Window and Help. And these are called as main toolbar panel. Here is the Explorer pane and it is the attribute table. And here we go to draw the logic circuit. So it's called as drawing canvas. Now I move to the main menu. Here we can see file. When I click the file, you can see new option here. When I if you want to get a new Logisim software, you can get it from this option and move to the open. You can open the already saved projects here. Then here save as, and export image is here. If you want the image of the circuit, you can get it from this export image option. Then I'll move to the edit option. Here you can see undo, cut, copy, paste, delete, duplicate, select all. And I move to the project. Here add circuit, we can add circuits in this Logisim, and it's made by sub circuit. And here analyze circuit, we can get the truth table of the circuit drawn by us, or we can get the KMap also. Then here simulate, here simulation enabled, reset simulation, and those three tick once, tick enable, tick frequency. Both those three are used to clock pulse. And now I'll move to the main toolbar panel. Here you can see clearly the hand icon, and this hand icon is used to change the value within circuit. I'll show you what are the usage of the hand icon. And here the pointer icon, I can connect with the wire between the circuits or inputs outputs using the pointer icon. Then here's the text icon, I can edit text in the circuit using this text icon. And this is the input pin, this is the output pin, and here a NOT gate, and this is an AND gate, and this is an OR gate. And when we see the Explorer pane, here you can see wiring, gates, plexes, arithmetic, memory, input or output, and base. I click the wiring, and here you can see splitter, pin, clock, ground, and more some wiring options. Then I move the gates. Here you can see the whole gates are reduced to the circuit design. So here NOT gate, AND gate, OR gate, NAND gate, NOR gate, XOR gate, and XNOR gate. Here in plexers, we can see multiplexer, demultiplexer, decoder, encoder. And here arithmetic. You know what is arithmetic? It's a calculation. So here we can see adder, subtractor, multiplier, divider, and move to the memory. Here some flip-flops are there, and register, counter, RAM, ROM. And I'll move to the input output. Here input some, here there are some input options, and button, joystick, keyboard, LED, 7-segment display is the output. Then I show you how to draw a simple diagram in this Logisim software using those options. Then I'll take a AND gate, and here you can see there are 5 connecting locations are here, but I want only 2. So how can I change it? Here you can see in the attribute table number of inputs. So when I click the number of inputs option, you can see more inputs also. Then I'll scroll up and I'll move to the 2 inputs. Then I click it. Then you can see the change. So I want to delete it. Okay. Then I'll get another copy of the AND gate from here. You can see the change. Then I'll take a OR gate. Then I want to change it also to 2 inputs. Then I'll take an NOT gate. Then here's the input. So I'll take 3 input. And I'll connect it. Look at here how I connect it. You can adjust the circuits like dragging this with mouse. Like this also. Then I'll connect it with the AND gate and this OR gate also. Then I'll put the output. Okay. I'll take one LED also. I'll connect it with the output. Then I'll show you how to run the circuit. So here the hand icon. Then I select the hand icon and move to the, sorry, I forgot to add one input. Fine. Then I'll move to the hand icon. Here I want to change the inputs. So I click in this 0, you can see the change. Here's the 0 option, and when I click, it's changed to 1. And here also I click it. So you can see the change in the input and output and LED also. Here I want to put the label for every input and output and LED. Here I put A and I'll change the label font size to 18 and font style to bold. Then I'll change it. I'll rename it to this is as C and output as Q. And LED as LED. Okay. I'll change it. Because it's hide the LED color. So I'll add the label using text. Okay. Okay. Now here you can see the red light. If you like to change a color, what you like, you can change it also. Here you can see in the attribute table on color. When we click the on color section, here you can see more colors here. I'll choose red color. You can choose any color in this. Then off color also. Here off color is dark green or black. So I'll choose another color like this. I didn't choose it, I just throw it to you. Then I cancel it. Okay, so this is the basic trial of the usage of the Logisim software, and you can see it clearly. Now I'll move to the presentation slide. Here, simulator tools available for logic gates based implementation. Logic circuit for digital system. When we consider about the logic circuit for digital system, mainly we can divide that into two types. They are combinational circuit and sequential logic circuit. The main difference between them is combinational circuits outputs are determined from present inputs. So it's depend only in the present input. When we consider about the sequential logic gates, they are in contrast where they not only gives the output by seeing the present input, but also they see the past inputs values, where it has a special element called addition to logic gates. It has a special element called storage element, that means memory. It can store the past values, we can use it later on further circuit purposes. So in combinational circuit, the output is determined only by using the present input. But here the output is the results of the state of input and storage elements. So it will consider both the state of input element and the storage element. Here you can see the difference of the combinational logic circuit and sequential logic circuit. As I told you before, outputs are determined from present inputs, and these circuits don't have any memory storage elements and don't have capability to store any state. Combinational logic circuits are time independent. Interconnection of logic gates. Performance operation specified logically by a set of Boolean functions. It's faster and better than sequential logic circuits. And move to the sequential logic circuit. Outputs are determined from both present and past inputs. It employs a storage element in addition to logic gates, and output is a result of state of input and storage elements. Sequential logic circuits are time dependent. Interconnection of flip-flops. Performance operation specified mainly used for storing data. It's slower and low performance as compared to that of combinational circuit. Now, let's see more about combinational logic gates. Here you can see the block diagram of the combinational logic gates. We are giving many inputs like A, B, C up to n number of inputs. And here we will receive output as A bar, B bar, C bar up to M. Here we can note that point that n number of inputs are from an external source, and this m number of outputs variables are reduced by the internal combination of the logic circuit. They are also sent to an external destination. Combinational logic is used in computer circuit to perform Boolean algebra on input signal and on stored data. So you can see the sample combinational circuit. And I will show you how to draw a sample combinational circuit by using Logisim. Here I already draw a combinational circuit. Now I'll again draw it. So I get gates from here and an AND gate inputs 2, and I copy this, and I get an OR gate, output, and I get a LED, and 2 inputs, 1, 2 OR gate. Then I'll join the gates in proper way. I connect the AND gate with OR gate, and here also. Then I connect the wire with the output, and okay, you can't connect the output with this side because here is the connection edge. So I connect like this. Then I'll show you how the circuit is run. When I click the input as A1, so now you can see the change in the output. Here you can see LED color is red color, and here the change 0 to 1. This also. So this is the sample circuit, sample example for the combinational circuit. Now I move to the presentation section. Here, examples of combinational logic circuits, and those are adders, subtractors, multipliers, multiplexers, demultiplexers, encoders, decoders. And I'll move to the sequential logic circuit. Sequential logic circuit also combinational logic circuit with memory. The output of a sequential logic circuit is depending on present input and also on the present state. The present state is defined the present output and next state also. At the beginning, I have told you that our digital circuit for digital system includes mainly 2 types. They are combinational logic gates and sequential logic gates. When we consider about the combinational logic gates, the output will be as a result of the present input, and when we consider about the sequential logic gate, in contrast combinational logic gates, here the output will be the sequence of input and internal state. That is the main difference also between those two. Here in this sequential logic gates, in addition to logic gate, there will be a memory element will be present. This is the main difference. And when you see the block diagram of this, also you can understand it clearly. Here the inputs, outputs are there. And also here, in addition to the circuit memory, also there. So function of the memory element is to save the past output. It will be used into the next input. So some examples of sequential logic circuits are, there are two types of sequential logic circuits, and they are asynchronous and synchronous. Examples of sequential logic circuits: latch, flip-flop, counters, frequency divider, and register. We will see about those both combinational logic circuit and sequential logic circuit in the next video. Let's meet in the next video. Till that, goodbye.